Using the command line. End. File and Directory Management. Armin Shariarian. Using the command line. You will find over the course of this book that I have a great fondness for the command line. There are a lot of reasons for this. For one, I started in computing when terminals didn't have what we call full screens. And we certainly didn't have desktop environments. What we had was primarily command lines. As a result, I got used to typing. When I started on Unix systems, all I had was a command line, so I needed to get used to the command set available there. The other reason for getting comfortable with the command line is that you can't always get a UI. You may be working remotely and connecting over a network. This may get you only command line programs without additional work. So, making friends with the command line is useful. Another reason for getting used to the command line and the locations of program elements is that GUI programs may have failures or may leave out details that could be helpful. This may be especially true of some security or forensics tools. As one example, I much prefer to use the Sleuthkit, TISC, a collection of command line programs, over the web-based interface, Autopsy, which is more visual. Since Autopsy sits on top of Task, it's just a different way of looking at the information Task is capable of generating. The difference is that with Autopsy, you don't get all of the details, especially ones that are fairly low level. If you are just learning how to do things, understanding what is going on may be far more beneficial than learning a GUI. Your skills and knowledge will be far more transferable to other situations and tools. So, there's that too. A UI is often called a shell. This is true whether you are referring to the program that manages the desktop or the program that takes commands that you type into a terminal window. The default shell in Linux is the Bourne Again shell, Bash. This is a play on the Bourne shell, which was an early and long-standing shell. However, the Bourne shell had limitations and missing features. As a result, in 1989, the Bourne Again shell was released. It has since become the common shell in Linux distributions. There are two types of commands you will run on the command line. One is called a built-in. This is a function of the shell itself and it doesn't call out to any other program. The shell handles it. The other command you will run is a program that sits in a directory. The shell has a listing of directories where programs are kept that is provided and configurable through an environment variable. Keep in mind that Unix was developed by programmers for programmers. The point was to create an environment that was both comfortable and useful for the programmers using it. As a result, the shell is, as much as anything else, a programming language and environment. Each shell has different syntax for the control statements that it uses, but you can create a program right on the command line because, as a programming language, the shell will be able to execute all of the statements. In short, we're going to spend some time with the command line because it's where Unix started and it's also powerful. To start with, you'll want to get around the filesystem and get listings of files, including details like permissions. Other commands that are useful are ones that manage processes and general utilities. File and directory management. To start, let's talk about getting the shell to tell you the directory you are currently in. This is called the working directory. To get the working directory, the one we are currently situated in from the perspective of the shell, we use the command pwd, which is shorthand for print working directory. In example 1-1, you can see the prompt, which ends in hashtag, indicating that the effective user who is currently logged in is a super user. The hashtag ends the prompt, which is followed by the command that is being entered and run. This is followed on the next line by the results, or output, of the command. Example 1-1. Printing your working directory. Root at rosebud hashtag pwd. When you get to the point where you have multiple machines, either physical or virtual, you may find it interesting to have a theme for the names of your different systems. I've known people who named their systems for A Hitchhiker's Guide to the Galaxy characters, for instance. I've also seen coins, planets, and various other themes. For ages now, my systems have been named after Bloom County characters. The Kali system here is named for Rose Bud the Basilope. Once we know where in the file system we are, which always starts at the root directory, / and looks a bit like a tree, we can get a listing of the files and directories. You will find that with Unix/Linux commands, the minimum number of characters is often used. In the case of getting file listings, the command is ls. While ls is useful, it only lists the file and directory names. You may want additional details about the files, including times and dates as well as permissions. You can see those results by using the command lslaw. The l specifies long listing, including details. The a specifies that ls should show all the files, including files that are otherwise hidden. You can see the output in example 1-2. Example 1-2. Getting a long listing. Root at rosebud hashtag lslaw. Starting in the left column, you can see the permissions. Unix has a simple set of permissions. Each file or directory has a set of permissions that are associated with the user owner, then a set of permissions associated with the group that owns the file, and finally a set of permissions that belong to everyone else, referred to as the world. Directories are indicated with AD in the very first position. The other permissions available are read, write, and execute. On Unix-like operating systems, a program gets the execute bit set to determine whether it's executable. This is different from Windows, where a file extension may make that determination. The executable bit determines not only whether a file is executable, but also who can execute it, depending on which category the execute bit is set in, user,